Hello, these are our presentation for the online voting system that we use blockchain technology. Here are the format presentation for the participate in voting system from their own computers that that application uses blockchain. Although in Turkey or in most of the countries, elections are not done electronically, or there is no voting system electronic. There is no electronic voting system using blockchain, only old methodologies. So we want to change that. We also want to ensure that the counted votes are authentic. In the blockchain, there won't be any fraud voting as happens in Turkey. And this study tells that the risk of adopting an electronic voting system because software challenges insider threats and vulnerabilities, and challenges are auditioning. Finally, we have an idea to rectify these problems by changing the current voting system by using blockchain. The objective is that the users can vote from anywhere in the world if they have citizenship, and there is no standing queue as happened earlier before in Turkey. It saves a lot of time, secure, and there is no fraud, and easily attain the 100% of vote in every constitution. So, lastly, the 88% of Turkey participated in elections. Hacking and manipulating votes won't be easy in blockchain rather than old methodologies or normal softwares. Here's the server. There's a paper called Security Analysis of India's Election Voting Machines. Here's the author and the description. There's also a conceptual secure blockchain-based electronic voting system, and here is the description of the paper.
Proposed work. We have proposed an idea to design a web application with individual login for voters using blockchain. We have worked on the following ideas by having two sets of modules. One is used for the election commission and another one for the voter. And election commission creates elections and adds registered candidates along with the parties for contesting the election. While polling the vote is stored on database of which the election commission fetches the vote count. Our proposed solution will include four requirements: authentication, anonymity, accuracy, and verifiability. You can see the blockchain structure of each candidate in this picture. And you can see the representation of our system in this picture. Then, let me explain methodology. First, requesting to vote. The user will have to log in to the voting system using his credentials. In this case, the e-voting system will use his social security number, his address, and the voting confirmation numbers provided to registered voters by the local authorities. The system will check all information entered, and, if matched with a valid voter, the user will be authorized to cast a vote. Second one is casting a vote. Voters will have to choose to either vote for one of the candidates or cast a protest vote. Casting the vote will be done through a friendly user interface. Third one is encrypting votes. After the user casts his vote, the system will generate an input that contains the voter identification number followed by hash ID of the previous vote. This way, each input will be unique and ensure that the encrypted output will be unique as well. The encrypted information will be recorded in the block header of each vote cast. It's a one-way hash function that has no known reverse to it. And the fourth one is adding the vote to blockchain. After a block is created and depending on the candidate selected, The information is recorded in the corresponding blockchain. Each block gets linked to the previously cast vote. Design and implementation. A secure server that only allows clients with authentic names and passwords to cast votes. Server checks for the authenticity of the client and also checks if the client has already voted. It returns a message to the client according to the security check. Admin registers voters and the voter list is stored in a CSV file. Server can match the client's name and password with the TXT file. If the details match, then the voter is redirected to the secured voting page. The voters will then cast a vote by mentioning the poll symbol of the candidate from the candidate list provided by the server. The system can handle multiple clients and creates a new thread for each of them. One client can cast a vote once and only once. And there is requirements, and you can see the requirements in the screen: MySQL, Solidity, MetaMask, Visual Studio, Community. Tools used. We used these tools in our project. When programming, Python, JavaScript, HTML, Solidity, PHP, Bootstrap, CSS. When connecting, socket programming, protocol, TCP, user interface, XAMPP, data storage using CSV files, data updates, SQL, OS calls, Windows. Conclusion. We have proposed an online voting system based on the blockchain technology. The system is decentralized and does not rely on trust. Any registered voter will have the ability to vote using any device connected to the internet. The blockchain will be publicly variable and distributed in a way that no one will be able to corrupt it. With the help of our system, we also demonstrated its shortcomings, which will be covered in subsequent research publications. Thank you for listening.